In this video, we're going to calculate probability. We're going to look at the basic probability and do some examples with how we can kind of view events. Whether we're talking about in theory or with data, meaning we're actually looking at solid numbers in the world, the probability is the number of ways an event can occur over the total number of outcomes. So we're going to use some kind of specialized examples to do this. Let's say that our sample space lists all the numbers 1 to 10. Okay. And let's say the event A is the numbers 1 through 5, and the event B is the numbers 4 through 8. Let's find the probability of A and the probability of B. Okay, so for the probability of A, we would be looking at 5 possible outcomes out of 10 total outcomes, which we could write as 1 half or zero point 0.5. Or if you want, you could write it as a percent, 50% would be fine. Most math people just stick with the 1 half or the decimal because they're kind of lazy and it takes more effort to write a percent symbol. So there you go. I'm just making that up, but it sounds good. So let's say then we want to find the probability of B. Well, B also happens to have 5 outcomes. If I count up those 5 possibilities out of our sample space of 10 possibilities, which means that we're also looking at 1 half or zero point 0.5, or if you're feeling like it, you could write 50%. So it's the idea is that we're just strictly counting how many ways our event of interest occurs out of the total possibilities. So for or means that we're looking at two events and we're saying it could be in one or the other or both. Okay. That's an or. So for example, let's say we're looking at our same set, our sample space, 1 through 10. And I don't know, maybe these are representing 10 papers in a hat that are numbered 1 through 10 or something like that. Okay. And the possibility of the event A is that we're wondering we'll pull a number 1 through 5, and B would be numbers 4 through 8. Okay. So probability of A or B. So we're looking at outcomes that occur in both A or B or both. So I'm going to start by listing what A or B is. Let me start with that. So A or B would be all the numbers 1, 2, 3, 4, 5. That's A. But now, okay, B picks up with 4 or 5, but I'm not going to repeat that. That's already being counted. 4 and 5 is already listed. So I'm just going to list 6, 7, 8. So I don't need to like be repetitive. Okay. If 4 is in both sets, I'm not going to list it twice. It's going to count as one possible outcome. All right. And then if I wanted to find the probability of this, what that means is I want to know that I could possibly get one of these numbers, 1 through 8, when I know I'm working with 10 total. So that would be 8 out of 10, or 4/5, or as a decimal, that's 0.8. Or if you're feeling sassy, 80%. Okay, and is when it's in both events at the same time. It has to occur in both A and in B. So for this example, then, same sample space, same A and B, we're saying that it has to be in both of them. And there's only two events or outcomes that are in both of them, right? 4 and 5 happen to be listed in both A and B. Therefore, A and B, if I just wanted to list the possible outcomes, that's going to be 4 and 5. Okay. The probability of A and B would then be two possible outcomes out of 10 total, or as a reduced fraction, 1/5, or 0.2, or 20%, if you really love those percents. Okay, so complement. The complement of an event, which they use this special notation, which uh, mathematically they read that A prime. Okay, that little slash symbol is a prime. A prime consists of all outcomes that are not in A. By the way, I have seen some books use A to the C as a complement. Wow, that's a terrible C. They'll use that instead. Here, let me zoom in. Whenever I'm having trouble writing, I find I just need to zoom in a little bit closer. There we go. All right. So that's another possible way of writing the complement of an event. So it's all the things that are not in A. So let me give you an example. Let's scroll down here. I actually picked a different example for some weird reason. But there you go. Let's say this time our sample space is 1 through 6. So the numbers 1 through 6. And A is going to be the numbers 1 through 4. So again, think of the hat like, there's numbers 1 through 6 numbered in there. And we want to know that, we get either 1, 2, 3, or 4. So A complement or A prime would be all the other possibilities that aren't accounted for in A. So that would be 5 and 6. The probability of A complement is 2 out of 6 in this example, or 1/3, or 0.3 repeating, but I think I'll just stick with fractions. So the probability of A happens to be 4 out of 6, because there's 4 outcomes possible out of 6 total, or 2/3. And as this note up here mentions, right here, okay, when you add these two things together, it should total to 1. And that makes sense because when I add 1/3 and 2/3, that does total up to 1. So yay, that does actually work mathematically speaking. But it also works conceptually because if the complement is representing everything not accounted for in A, in the sample space, A and its complement are always going to total up to the entire sample space. Every outcome is going to be accounted for in A and A prime. Okay, so the conditional probability. The conditional probability, which we say of A given B, and it's written with this notation, okay, with this kind of vertical slash. This is the probability that an event A will occur, given that an event B has already occurred. And this is the key statement here. It reduces the sample space. So let me give you a real world example, and then we'll kind of look at an actual mathematical example. So real world example is, let's say, we're interested in how on time you are getting to work. All right. And let's say you're driving to work and you go out to your car and your battery's dead. All of a sudden, the probability of you being on time has changed because this event of the battery dying has changed your odds that you're going to be able to get to work on time, depending on, whether you have the ability to get the battery jumped or have an alternate transportation or, whatever scenarios you could possibly have in that case. That's what we mean by given some other event happens. Okay. But what it does is it changes the odds now. Because when I'm talking about in general that you're on time, that does account for these weird cases that maybe something odd happens. Okay. But if I tell you, hey, something odd has happened, now we're talking in a more specific looking scenario. And so it's reducing what we're looking at, it's reducing our possible outcomes. So let me give you an example. Suppose we toss a fair die, okay, 6-sided. 1 through 6 are the possible outcomes, which they graciously listed there for us. And then we're told that the event A is getting a 2 or a 3, and the event B is getting an even number, okay? Find the probability that A is going to occur, given that B has happened, okay? So what that means is we're saying B is going to happen, meaning I'm telling you, whatever the die, when it's got rolled, it's coming out to be an even number. So I'm telling you, it's got to be one of these possibilities, a 2, 4, or 6. Now I'm asking, what's the likelihood then that A is going to happen? That we get a 2 or a 3? Well, right away, 3 isn't even a possibility because 3 isn't even an even number, okay? So we're already saying that in order for A to happen, that means we have to roll a 2. So the probability that A is going to happen, given that we're looking at an even number, means we have to roll a 2. So there's only one outcome possible out of 3 total. The 3 that it could be even, a 2, 4, or 6. So we reduced the sample space based on B, what happens in B. And we had to look at what possibilities would actually work for A now knowing that B has happened. So we're looking at is A and B, because 2 happens to be the outcome they have in common. And that's what and means, the outcome they have in common. All right, so we'll put this together in kind of a large drawn out example here. So let's start with the sample space. This time we're going to list it. So it's all whole numbers starting at 1, less than 20. Whole numbers means no decimals. So we start with 1 and we're going to list out all the numbers until we get to 20. And I know you're like, hey, that takes a while. And I agree, it does. But I'm going to follow the directions and I always want to get my points. So I'm going to list them all out. We typically use these little squiggly brackets, by the way, whenever we're listing out all the outcomes like this. So it is proper notation to use those squiggly brackets. All right, so now we're given 2 events and they kind of describe them to us. A are even numbers. So if this is our sample space, we're looking at the numbers 1 through 20. The even numbers are going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. And B, numbers greater than 13, greater than 13. So if it's a greater than or equal to 13, I'd include 13, but 13 is not going to be counted. It's going to just start at the numbers 14 and list up until we hit 20. All right, so let's look at the probability of A. So the probability of A would be there's 10 outcomes in A out of 20 total, which we could just write as 1/2 or 0.5. I really don't care. B, 2, 3, 4, 5, 6, 7 would be 7 out of 20, which we could just leave it like that. 7 out of 20 is fine. But if you wanted to go ahead and put it into decimal form, that would be 35.35. Oops. Or 0.35. Either one is fine. Unless they specify, like round to a nearest certain number or write as a reduced fraction. Like they may specify, okay? A and B. So now we're looking for things they have in common. That's what and is, right? And what they have in common. So it looks like we're not going to even start till we get to 14, right? So 14, 16, 18, 20, because it's just even numbers when we're talking about A. Okay, now for or, we're putting the 2 sets together. So we'd start with listing A. Okay, so I'm going to start with A, 2, 4, 6, 8, 10, 12. And then when I hit 14, now I'm going to start listing B, because from this point on, they have numbers in common, but B has a few extra. So I want to make sure I get all of those. 19, 20. All right. So the probability of A and B, well, that's going to be 1, 2, 3, 4 out of 20, which is 1/5, or you can write 0.2 if you feel like it. Or let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 out of 20. Which would be 65.65 if I write it as a decimal. You don't have to, though. I'm just going to write them down every time so that you know they're the same. All right, here, let me zoom out a bit because I want to kind of still refer to A and B. All right, so A prime or A complement. So all the things that aren't in A. Well, since A is all the even numbers, A complement is going to be all the odd numbers. Definitely didn't give myself enough space here. That's okay. 1, 3, 5, 7, 9, 11, 13, 15. I'm going to go to the next 17 and 19. So close. All right. So the probability of the complement is also 10 out of 20, which is 1/2 or 0.5. I encourage you, by the way, if you feel like I said it too fast, pause the video, repeat, right? Go back, look at what you were talking about. Don't be afraid to to pause it and make sure you do understand, because you're just learning this terminology and I'm kind of just going through it because, well, hey, I'm talking to myself here. All right, so if you add A and A complement together, that's always going to be 1, by the way. That's how the complement works. So that one was easy. And then let's look here at H. So now we're going to get into those conditions. So the probability of A given B. So here, let me zoom out a bit just so I can see. Okay, so the probability of A given B. Now remember, A is all the even numbers, but we're told that B has occurred. So automatically I know that I'm looking at only outcomes in B. So that means I'm looking at 1, 2, 3, 4, 5, 6, 7 outcomes. And of those 7 outcomes, how many of them occur from A? Well, it's all the even numbers, right? So that's 1, 2, 3, 4 out of 7. And I'm not going to bother putting it as a decimal. 4 out of 7. Okay, so for B over A, that's different. Now we're saying we're looking at even numbers. We're limited to looking at the even numbers. So we're looking at those 10 even numbers. And I want to know the probability that it's going to be one of the numbers that are 14 or higher, right? So there are 4 numbers that occur in A that also occur here in B, right? Those are what they have in common. So those same 4 numbers are being counted for in the next problem. So 4 sevens and 4 tens. Are the probabilities equal? No, they're not. It does tell us something when they are equal, but we'll talk about that in the future. For right now, what we're noticing is the 4 is what's in common in both numerators, but the denominators change. We're no longer out of 20. Now we've limited ourselves to looking at things in B. B is like our new sample space in this one. So we're only looking at those 7 outcomes. And here we're limiting ourselves to A, all the even numbers. So only the even numbers are we looking at, those 10 even numbers. And we're wondering of B, what ones could possibly occur.